If you're a beginner JavaScript programmer or have no experience writing code before, then this video is for you. What I'll be doing is walking you through 4 beginner projects that are fun, simple, and easy to follow along with and help you learn JavaScript in a practical, hands-on way. Rather than watching a ton of theoretical tutorials, which can be long and boring, we're just going to jump into some projects. I'm going to stop every now and then, explain the concepts that I'm using, but you'll be able to see how we actually apply everything and build something out that's fun, interesting, you can show to friends, family, maybe your spouse, etc. This is going to be a great video for anyone really just looking to get their hands dirty and to build something out in the next hour or two. All right, so before I get into the environment setup here, I'll just mention what the 4 projects are. The first project is a quiz game. The second project is a random number guesser. The third is rock, paper, scissors with a little bit of a twist on it. And the last is a choose your own adventure game. These are going in order of ascending difficulty, meaning the first project will be the simplest, then it'll get a bit more difficult until we get to the last project, which is slightly more challenging. That said, even beginner programmers will be able to follow along here, and if you want to skip forward to one of the projects I've listed, all of the timestamps will be available in the description, and you should see them on the screen right now. What I will also mention is that if you want to get better at programming, I do have a programming course. It's called programmingexpert.io. If you guys want to purchase that and support me, I'd greatly appreciate that. You can look at it from the link in the description. And if you're at all interested in Web3 and blockchain technology and kind of the development side of that, then you can check out Blockchain Expert, my other course, from the link in the description. All right, let's get started with the environment setup. If you already know how to write JavaScript code and you've got things set up and you have Node.js installed, feel free to skip through this portion. But for any of you that don't have this or have never written code before, pay close attention here, as I walk through this setup. So what we need when we're writing code is something that can execute our code and then a place where we can write our code. Now for JavaScript, you have a few different options, but in this tutorial, I'm going to use something called Node.js. Now Node.js is actually a client-side application that allows you to run JavaScript directly in your terminal or your command prompt. You don't need to really know what that means, but the first step in this tutorial for anyone who doesn't have this installed is going to be to go to Google and search Node.js. I'll put this link in the description as well, and you're going to download whatever the recommended version of Node.js is for either Windows, Mac, or Linux. You're going to go to the installer. So when you download this, it should go in your downloads or something like that. Double click the installer, run it, and then it should run or install Node.js for you. Node.js allows you to execute a JavaScript file so we can do all of our code directly in our terminal, and we don't need to open up something like a browser or interact with any HTML. Okay, so make sure you've got Node.js installed. Once you have that installed, we're going to install something called Visual Studio Code. Now, this is a code editor, which is a place where we can write our code. So just like Microsoft Word helps us write documents when we are, writing an essay or something like that, we have special tools called code editors or IDEs, integrated development environments, that allow us to write code, kind of get some syntax, highlighting, formatting, etc. So that's what Visual Studio Code is. Go to this website, again, download the recommended version for Windows, Mac, or Linux, double click the installer, install it, and then open it up. So at this point, you should be open in Visual Studio Code. Yours is going to look a bit different than mine because I have some settings and some themes and stuff. Don't worry about that. All you're going to do right now is you're going to go to File, Open Folder, and then you're going to make a new folder in some location that you can remember. So I usually just recommend going on the desktop. So you go to the desktop, make a new folder, again, Mac, Windows, whatever, doesn't matter. Call this something like Tech with Tim Tutorial, whatever you want to name it. Click Enter, and then open up that folder. So I'll actually just go through the step here so that I'm following along with you. From here, you're going to be brought into an environment that looks similar to this. What you'll do now is create a JavaScript file, and then we'll pretty much be off to the races and ready to write our code. So you can see on the left-hand side of the screen here, we have a bunch of different buttons. The tab you want to be in is the File Explorer, which is kind of the little files right here. You're going to click on this button, which stands for New File, or you're going to go to File, and then New File like that, okay? What we'll do is go to this New File button. It's going to pop up this little area, and we're just going to type something like script.js. Now, you can call this whatever you want, so long as you end it in a .js extension. .js stands for JavaScript, and that's the extension for any JavaScript code files. So I'm going to go ahead and hit Enter, and now I'm inside of a JavaScript file. From here, we're just going to make sure that our Node.js installation is working, and then we'll be ready to get onto the project. So we're just going to type console.log, and then inside of double quotation marks, we're going to type hello. So just exactly what I have on the screen here. Don't worry too much about it. Just type this in. Save your file with Control S or by going to File and then Save. And then what you can do is pop open this terminal from the bottom of the screen. So you can see I kind of put my mouse down here and I can drag this up. You also can hit Control and then backtick on your keyboard. Backtick is at the very top left-hand side of the keyboard where the tilde or the squiggly line is. And that's going to toggle the keyboard for you. For most of you, it's going to be easier just to kind of grab this from the bottom of the screen. From here, it's automatically going to open the terminal in the same directory where your file is. So what you'll do now is you'll just type node and then the name of your JavaScript file, which in this case is script.js. Okay, if you named it techwithtim.js, if you named it main.js, then you're going to obviously replace script.js with that. So go ahead and hit enter, and you should see that you get hello appearing in the console. If that worked, then you're all set up and ready to go. If for some reason you got some error with this command, you're going to have to look up how to fix your Node.js installation. Unfortunately, I can't help you with that in this video, but you just need a way to execute this JavaScript file. Quickly recap, install Node.js, install Visual Studio Code, open up a folder in Visual Studio Code like I just showed you, create a new JavaScript file, and then run the file using node name of the file. Okay, that's how we do that from our terminal. If you're on Mac, Linux, etc., the steps are going to be the exact same. You're just going to see probably a few slightly different things depending on your operating system. That's totally fine. Follow the same steps. Okay, so we're all set up now. What I'm going to do is go into full screen mode, and we're going to begin our first project, which is a quiz game. Now, what I'll be doing is writing a little bit of code, then I'll be stopping, kind of explaining that code. So if something doesn't make sense, just hold on. I'm sure I'm going to explain it in just a minute or two. All right. So for our quiz game, let's begin with what we want to build. The idea here is to make something that you can give to like your friend, your son, your spouse, whatever, that's a quiz about yourself or a quiz about something that you know a lot about. So in my case, I'll make a quiz about different computer components, but for you guys, you can make a quiz like, what's my favorite food? What's my favorite pastime? What do I do at night? Where do I go at 9 p.m. on Thursdays? Whatever you want to do, right? You can make this as personal as you want. So I'll give you a bit of a template for the project, and then you can extend this on your own and make it as long as you see fit. The idea is we'll keep track of the number of correct and incorrect answers, and that way, what we can do is tell them you got 70% on this quiz, or you got 30%, or whatever the score is. Okay, so let's begin. The first thing we need to do is get some console input from our user. That means we need to allow them to type something into the screen. So how do we do that? Well, the way we do that is actually by installing a package, which is going to give us access to some function, which we can use to get some input from the user. So we're going to go back to our terminal here. So just open this up, right? And we're going to type npm install and then prompt-sync, okay? npm stands for Node Package Manager, and this is something that installs different dependencies on your computer you can then use within your JavaScript files. So we type npm install prompt-sync, and that's going to give us access to a module which will allow us to kind of ask the user to type in some input, okay? So just run that from your terminal. You're going to see some output here. Don't worry if you get any vulnerabilities or issues. That's totally fine. Now, once you've installed that, I'm just going to clear my terminal here. We're going to go to the very top of our file, and we're going to say const. This is how we declare a variable. We're going to say prompt is equal to require, and then inside of double quotation marks, we're going to say prompt-sync, and we're going to put another set of parentheses here. I know this is a little bit confusing. It looks like a lot of gibberish. Just type exactly what I have here. This is kind of the most complicated line that we need. What this does is load in this module, so it requires its use, and then we get access to it in this prompt variable. That now means we can use this prompt variable to actually grab user input, okay? So we said we're declaring a constant. This is a type of variable in JavaScript. We're saying this is equal to require. We're requiring prompt-sync module. And then we put another set of parentheses here. I'm not going to explain exactly why we need those, but just make sure you have the second set so you have this line exactly as you see it here. Now, let's just quickly test this code out by typing prompt, and then we're just going to say enter something, and then a colon and a space. Make sure you add the space. There's a bit of separation between where we're going to be entering some code. And then we can clear, and we can run our code again. Notice, by the way, in the terminal, you can use the up and down arrow key to cycle through commands you've typed before. So I'm hitting the up and down arrow key, and it's kind of going through my command, so I don't have to type it every time. Anyways, I'm going to hit node here. Notice it says enter something, and you can see my cursors appearing in the terminal. So now I can type something like hello world, and then we just continue with the rest of the program. Perfect. So prompt gives us access to whatever the user types. So now we're quickly going to talk about some variables. We're going to define those and use them, and then continue on from there. Okay, so what we're going to do to begin here is we're going to say const, and we'll just say value is equal to prompt. Now what we're doing here is declaring a variable. A variable is really just some named value that gives us access to some kind of piece of data. In this case, the data we're going to be getting access to is something known as a string. Now within our programming languages, we have some different data types. These are the different pieces of information essentially that we can store in our program. So we can have numbers, we can have a Boolean value, something like true or false. We can have strings, arrays. We'll talk about those later as we go through the rest of this video. And I'm sure for many of you, you already know what those data types are. But what this prompt function is going to do for us is it's going to give us something known as a string. Now a string is anything that is surrounded in double or single quotation marks. There's some more complicated strings as well, but typically your strings are going to be in double or single quotation marks, meaning if I have something like 1, this is the string 1. If I have something like hello, this is the string hello, and usually they'll highlight in yellow or some color for you in your code editor. Okay, so what we're doing is we're saying we're going to have a variable. We've made this a constant. Now a constant is a variable whose value cannot change, and we're saying that's equal to this function, which gives us some type of string. So what I'm going to do now is I'm going to type console.log value. And what this is going to do is print out or log to our console, which is really our terminal, the value that we typed in. So whatever gets stored in this variable, we can then access by using the name of the variable here inside of our console.log. Again, I know this is a lot of information, especially if you've never programmed before. I'm going to try my best not to overload you, but these are kind of fundamental concepts we need to go over. So I'm going to run my code again, and you're going to see I get enter something, and then I can type in hello. When I do that, notice hello gets printed to the screen because that's what we typed in from this function. Again, function gives us some kind of string. This is a data type, a piece of information we can have in our program. We store that in the variable value, and then we access what's stored inside of that variable by using the variable name. Notice if I try to use something like value1 here and I run the code, I actually get an error. So you can see this kind of reference error is popping up saying value1 is not defined. And that's because no variable called value1 exists. If I wanted to print value1, so I wanted to see that in my terminal, then I would actually need to surround this in a string. So I tell my computer and I tell JavaScript, hey, I'm not trying to access a variable. I actually want to print out literally value1. So now if we clear and run, and I type something like hello, you can see I get value1 this time because I put it inside of a string, okay? So that's kind of what we've learned so far. We know what a string is, anything surrounded in quotation marks, and we know how to access a variable. Great. So now we're getting something typed in from the user. And I just want to show you if I try to do something like value equals 1 here, and I go ahead and run my code, you're going to notice I get another error. Now the reason is I'm getting assignment to constant variable. Now this is where we'll quickly talk about the types of variables, and then we'll continue on with the rest of the code. So here we're using a constant. Now a constant is something that can't change. So think of constant value, right? Or think of something like gravity, which is a constant. This is something that's always going to be the same. So we have the ability to define on our variables if we want them to be able to change or not change. In this case, we've said, well, we're not going to change this variable, so we'll make it a constant. However, if we wanted to be able to change the value of it later on, we'd have to use this keyword known as let or var. For now, just use the let keyword, but there is this var keyword, which is effectively going to do the same thing. It just has a few small differences that we don't need to get into right now. So I'm going to say let value equals prompt. And when I use let, this says we're setting up a variable which can be dynamic, which can change. So we can modify its value without a problem. So now if we run our code and we type something in, you notice there's no issue because we used let instead of const. Okay. So already in 7 minutes there, you've learned more than you probably would in 5, 6 different tutorials for JavaScript. Okay, we have our variable now, and what we should probably do is start working on our quiz. We understand the fundamentals, now we can move on and kind of create this quiz game. So the first thing we want to do is probably welcome the user to our quiz. So we're going to put a console.log here, and we'll just say something like welcome to the computer hardware, if we can type this correctly, quiz, exclamation point, okay? So now the program is going to start. It's going to print this message to the user. And the first thing I think I want to ask the user is if they'd like to maybe play the quiz, or maybe we'll just go right into question 1. In fact, we can just do question 1. So what I'm going to do here is I'm going to say const, and I'm going to say answer1, which is a variable. And this is a valid variable name, by the way. You can use numbers in your variable name. The rules for the variable naming Or if you wanted to have something like a space, you'd have to use an underscore. So if I wanted to do answer1 hello, I couldn't do it with a space. That would cause an error. Instead, I'd need the underscore to represent that space. Or I could then put a capital on the first letter here, so something like answer1 hello, to kind of space it out and indicate it's multiple words. This is something known as camel case, which is suggested when you're naming variables. Another rule is that you can't have any special characters. Something like an ampersand is not going to work. And you can't start your variables with a number, but you can have numbers inside of the variable, okay? So we're going to say const answer1 is equal to, and then we're going to ask a question. So what's the first question we should ask? We'll say something like, what is the brain of the computer? Question mark. Okay, and then we'll allow the user to type. Now we're going to be looking for a specific answer, and in this case, the answer we want is CPU, or central processing unit, okay? So now what we need to do is we need to check what their answer is, and we need to see if it's correct. If it's correct, we want to tell them they got it right. Otherwise, we want to tell them they got it wrong. So how do we do that? Well, we need a way to compare this value with the correct answer. So I'm going to make another variable here, and I'm going to say const, and we'll say correct underscore answer1 is equal to, and in a string, we're going to type CPU because this is the expected answer that we're looking for. Okay. Now what we'll do is we'll use something known as an if statement. An if statement allows us to evaluate something known as a condition and see if that's true. So we're going to say if answer1 is equal to the correct answer, then we're going to put a set of curly braces like this. Don't worry, I'm going to explain this in a second. And we're going to say console.log, you got it correct, exclamation point, like that. Okay, so what we've done here is we've set up an if statement. Now the syntax of an if statement is you write if, you put an opening parenthesis, and then you put something known as a condition. Now a condition is something that evaluates to true or false. Now, the way that this kind of works is that we have another data type in our program, or in JavaScript, known as a Boolean or a bool, okay? Now this is anything that is the value true or false. So these are the only two valid values that are Booleans, so true or false values, okay? Now, what we can do is we can write something known as a condition, which uses something known as a conditional operator to see if something is a true or false. So when I use something like 3 equal signs here, what I'm actually doing is I'm comparing the left-hand side to the right-hand side, and I'm asking if they are equivalent, if they're the same exact value and the same type. Now, there is a double equal sign as well. Don't use that right now. Just use the triple equal sign. We don't want to get confused with the double equal sign, which works a little bit differently, okay? So I say, is answer 1 equivalent to answer 2? Now, this condition here is going to give me the value true or false. Now, the way the if statement works is if whatever is inside of these parentheses is true, then it's going to execute what's inside of this curly brace block, okay? So this little set of curly braces here is associated with the if statement, and it's saying do whatever's inside of this set of curly braces only if this is true. Okay, if it's false, we're just not going to do it. We're not going to enter into that block. So let's run this and see what we get. And it says, welcome to the computer hardware quiz. What is the brain of the computer? And we're going to type CPU, and then notice it says you got it correct. Whereas if I run this and I type something like the motherboard, we don't get any result. The reason for that is that the motherboard was not the same as the CPU, and so we didn't enter inside of this block, meaning we didn't print this out. Okay? Now, there's a few more things to teach you related to this, but hopefully all of this is making a bit of sense, trying to kind of blur the line here between in-depth explanations and, actually writing some code. Once we get through all of this in this first project, we're going to go a lot faster. I just wanted to make sure that I cover all the bases in case you've never seen JavaScript before in your life. All right, so let's run this one more time. And I just want to kind of test something out. And this is what I would encourage you to do as well on your own. If you have a question, don't necessarily wait for me to answer it. You can try to figure it out by actually writing some code and modifying what you have. So for example, what happens if I type CPU with lowercase? That could be an answer. Someone could type that in without uppercases. And notice we actually don't get that output saying you got it correct. The reason for that is when we compare two strings in JavaScript, we're comparing them with their capitalization. So they're case sensitive. So what we actually need to do if we want to allow this answer, or an answer like CP and then lowercase u to be correct, is we need to convert either our expected answer or the answer the user types in to either lowercase or uppercase and then compare them against each other. So the idea here is that we keep our correct answer all in the same case. So in this case, I keep it completely in uppercase. which then means what I can do is I can take whatever the user types in and I can just convert it completely into uppercase, and then I can compare the two strings. So you're just going to compare them using the same case. So how do I do that? Well, there's actually a method, and a method is something that you can kind of use on a data structure or on a data type. And the way this works is you put a dot. So we have answer1, which is a variable. This variable is equal to a string. I'm going to do dot, and then this is 2, and then notice we have uppercase here, and put a set of parentheses. Now what this is going to do is it's going to take answer1, convert it completely into uppercases, and then give me that result kind of in place of this string, or in place of this kind of line or expression that you see right here. I'm trying to come up with the correct word there. It's not going to modify the value of answer1. Answer1 will stay the same, but what will happen is it will essentially inject what answer1 to uppercase is on the left-hand side of this equal sign, which then means we'll be comparing the uppercase answer1 to the uppercase correct answer to check if it's correct, okay? So let's clear and run, and now you can see if I type something like CPU in lowercase, we still get it correct because we converted that to uppercase. And even if I type something like CPU like that, we still get it correct. Now, last thing to show you here is that if I do add something like a space, so I have CPU space, it's not going to give us the correct answer, and that's because a string that contains a space in it is different than a string that doesn't contain a space in it, okay? So just keep that in mind. You're comparing every single individual character, and you can kind of modify the string in a way such that you're avoiding any incorrect answers when it is correct. It's just not exactly what you were expecting, okay? All right, so that's a good start. Now, one other thing to mention is that we should probably tell the user when they get it wrong. So what I'm going to do is add something known as an else statement. Now, an else statement is the complement to an if statement, and this block, so whatever's inside of this curly brace, is going to execute if the if statement is false, okay? So if this condition here is false, we don't do this. Instead, so else, we do what's inside of this block. Excuse me. So I'm going to take this console.log, and I'm going to say, you got it wrong. ... Okay, so now if we clear here, bring this up a little bit, and run the code, and we type something like, I don't know, GPU, you can see it says you got it wrong. All right, so at this point, we've learned quite a bit already, and we're actually ready to just extend this project and add a bunch more questions. Now, we'll add some more things to it, like keeping track of how many correct answers we have, but for now, let's just copy all of the code that we have, paste this here, and let's change our variables just so we don't get an error. So notice here, if I highlight this, it's saying cannot redeclare block scoped variable answer1. Essentially what that's saying is we already have a variable called answer1, so I can't make that again, right? Because this is defining the variable when I use this const block. So instead, I'm going to change this to answer2 and then correct answer2. Now let's come up with another question. We can do something like, what is better, a 3090 Ti or a 4060. I don't even know if they have a 4060 or not, but let's just go with that. And for the correct answer, this is going to be a 3090 Ti, okay? So now we can just change this around again. So we'll say answer 2 and then correct answer 2. And now everything should just work the exact same. We've just kind of copied and pasted this and changed the answer and the question. Okay, so let's save that and run. What is the brain of the computer? CPU, excuse me, 3090 Ti. And it actually says we got it wrong there. Okay, so let me check why we're getting that. Aha, so the reason we're getting this is because we converted our answer to uppercase when our answer here is in lowercase. So what I would need to do is just change this to be capital Ti like that. Or alternatively, rather than converting this to uppercase, I would need to convert this to lowercase. So if you do get an error, don't freak out, obviously. Just do kind of something like what I just did and look through your code and say, hey, why am I getting that wrong? Well, I typed it in lowercase, it was converted to uppercase. Okay, that's probably the issue. And you know that you're kind of going to have the error in one of these few lines here because this is where it's evaluating if you're getting it true or false, all right? So this happens all the time, even to experienced programmers like me. Don't worry if you get an error. Very, very common. In fact, almost a good thing when you're just learning how to code. Okay, so now let's run this again. What is the brain of the computer? CPU. And now we'll type 3090 Ti, and it says we got it correct that time, so we fixed it and it is working. Great. Okay, let's do one more question, and then we'll add tracking of the correct questions. So answer 3, correct answer 3, answer 3, and answer 3. And this time we can do something like say, what is the recommended amount of RAM in 2023? Now, this is going to be a subjective answer, but I'm just going to go with 16 gigabytes like that. This time, we're going to convert this to uppercase. So we're matching the casing of our answer, and that's all we need. That'll fix that. We're just going to need to make sure these are answer 3. They are. Okay, perfect. Let's run this. And CPU, 3090 Ti, and 16 gigabytes. Okay, awesome. All right, so our quiz has now been written. We have 3 questions. Obviously, you can add a lot more. I'm just not going to bore you by adding those right now. The next thing that we really need to do is keep track of how many correct answers we have. Now, this is fairly straightforward, but what we'd like to have is some kind of variable that's storing you have 1 answer correct, 2 answer correct, 3 answers correct, etc., and then display that to the user at the end. So the way to do that is to go at the very top of our program. It doesn't really matter exactly where, so long as it's near the top and before your first question. And we're going to say let correct, and we'll just say answers like this equal, and then 0. Now, one thing I'll mention, just because some of you may be getting upset about this, I've used underscores for these variables. Really, it's going to be best practice to not use the underscore and to do it in camel case, like I have suggested. Different programming languages have different conventions for the way you write your variables. In JavaScript, you are supposed to use camel case, so just because that's the convention, I'm going to change these here. Doesn't really matter. No one's going to get mad at you, at least, when you're just starting out. But just to kind of be correct, I'm going to make sure we're using camel case rather than underscores, which is actually a convention in Python known as snake case. Anyways, I have this variable, let correct answers equal 0. Now, this time we're using something known as the number data type, and this allows us to perform arithmetic so we can add to the number, subtract from the number, etc., which is different than the string, right? So the string 0 and the number 0 are different, like discrete, unique values, and they can be used differently because of the type of their data, the type of their information, right? So this is a number, meaning we can kind of add to it, subtract from it, etc. So now that we have this variable here, what we're able to do is go inside of our if statements, and after we console.log correct, or before, it doesn't really matter, but just inside of this if statement, we can actually write correct answers like this, which is our numeric variable, and then we can say plus equals 1. Now, saying plus equals 1 is going to add 1 to this value. Another way that we can do this is we can say correct answers is equal to correct answers plus 1, where we're saying, okay, well, what was the previous value of correct answers? Well, was it 1? Was it 2? Was it 0? Whatever it is, add 1 to it and then assign that to correct answers, so changing the value. Or a third way is we can write plus plus, and plus plus stands for add 1. Okay, this is known as the increment operator, just adds 1 to a variable in JavaScript. So I'm going to use plus plus, and I'm just going to go here and put these inside of all of the if statements. And this way, at the end of our program, it will tell us the number of correct answers that we had. Okay, I don't think there's much more to mention here. I will just quickly say, if you see these semicolons here, you don't actually need them, but what these stand for is a line termination or a line break, which essentially means stop reading the current statement and move to the next line. Okay, that's all that means. I kind of excluded mentioning them because you don't actually need them for your code to work, but since they're here, figured I'd mention that. Okay, so now we're going to go down to the bottom of our program, and we're just going to tell the user how many correct answers they got. Excuse me. So to do that, we're going to say console.log, you got, and then we kind of need to embed this number in the middle of the string. There's a few ways to do this, but the way that we're going to do it is we're going to put a comma. We're then going to put the correct answers, okay? And then we're going to put another comma, and we're going to say questions correct like that. So now what this is going to say is you got. It's then going to put whatever the value of that number is, so 1, 2, 3, 0, whatever, and then questions correct, and it's automatically going to add a space between all of these different values because that's how this function works. So if I come here now, I can print this out. Let's go CPU. Let's get this one wrong. So we'll go with 4060. Let's go with 16 gigabytes. And then it says you got it correct. You got 2 questions correct. Perfect. Now, last thing we can do here is we can actually give them some kind of percentage or grade indicating like what their score was on the quiz. So to do that, I'm just going to make a variable here, and I'm going to say total questions is equal to, and I'm going to specify the total number of questions that I have, which in this case is 3. Okay, so we're saying constant. We're making this a constant because we don't expect to change this value throughout our program. But if you did add another question, obviously you would adjust this and make this 4, 5, however many questions you have. Now what we can do is we can say you got correct questions correct, or correct answers, questions correct. Then we can say you scored, okay? And we can say correct answers, and we can divide this by using the / by our, what is this? Total questions, okay? And then we can multiply it by 100 by using the asterisk operator. And I'm just gonna put this in a set of parentheses so that we have this being applied before we have our multiplication. And then what we'll do is we'll just add a % like that, so they can see what their percentage score was. So say like 87.2, whatever, in this case, 33, 66, or 100, okay? So now let's run this. And what is the brain? CPU, 4060, and 16 gigabytes. And it says you got 2 questions correct. You scored 66.666666%. If you wanted to cut that off so that you didn't see all of those values, you do have the ability to round this. Now, I'll show this to you, even though it might be a little confusing. You can simply take math.round, and you can surround all of this here inside of that. Now, I know that gets a little bit messy, so what we might want to do here is say const % is equal to, and then put that there. And then we can just embed the % variable, so we're kind of structuring our code a little bit better and storing some intermediate values, making it a little easy to understand. I know I went a bit faster just because I want to move to the next project, but we're going to take math.round, and we're going to round the division of this multiplied by 100. That's going to round it to the nearest decimal value, so you are going to lose the values here. There's a way to keep them, but I'm not going to show that to you right now. So let's do this, CPU, and let's just hit enter there. It says you got 1 question correct. You got 33%. Perfect. Last thing, and then we'll move on. Some of you may want to actually have a % sign, and you might be getting a little mad that if you put the % sign here, there's going to be a space between it. So what you can do is actually perform something known as a string concatenation. The way you do that is you take this, which is a numeric value, okay? And you can't add a number to a string, because imagine this, right? I have something like 33 plus 7. Yeah, as a human, you can read that, but JavaScript doesn't understand this because adding a string to a number could result in kind of a weird value. Now, in JavaScript, this actually does work. I don't want to tell you to do that because you can get some strange values. So forget about the fact that it does actually work in JavaScript because you shouldn't do that. What you're going to do is you're going to convert whatever the numeric value is to a string. Then once it's a string, you can add another string to it, right? So if I have 33 plus %, then that's going to give me 33% because we're just kind of smushing the values together, which is known as a concatenation, all right? So we're going to take % plus that, but to do this, we're going to say %.toString, which is a method that, again, does not modify the variable. It just gives us the string representation of it. Then we put the % sign like that, okay? So let's clear and run, and let's go CPU, enter, enter, and you got 1 question correct. And it says you score 33%. We really should have you scored 33%. Okay, so that is project 1. I know there was a lot of stuff we covered there. I'm going to go faster in the next projects, but I was assuming you had 0 knowledge of JavaScript. We went through a lot of stuff here. Don't worry if it's a little bit confusing, but hopefully this was a bit helpful, taught you a bit about JavaScript, and you're ready to move on to the next project. All right, so now we are moving on to project number 2. What I've done is I've created a new JavaScript file. So I've called this script2.js, and I've just copied this line in here because we're going to need to use this. For this project, we'll be creating a random number guesser where we'll ask the user to input a number, and then we'll tell them if they are higher or lower than the random number they are attempting to guess. Then we're going to kind of keep track of how many guesses they've had, and we're going to tell them at the end, it took you, say, 7 guesses to guess this random number. Blah, 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 you get the idea. This will allow us to view a few new pieces of syntax in JavaScript and to practice working with math and numeric types rather than strings, which is what we focused on in the last project. Quickly, I'll mention that I am going to pick up the pace a little bit here. If I'm too fast for you, feel free to pause the video or to go to the playback speed and reduce that. Alternatively, if I'm too slow, increase the playback speed and you can get through this a little bit faster. Regardless, would love to hear your feedback on the last project and what you guys are liking or disliking so far. Please let me know in the comments. I always take that feedback to heart and kind of try to adjust in my future videos. Okay, so let's get started here. First thing we need to do is generate a random number. Now to do this, we're going to create a constant. We're going to call this random number. We also could call this target. I think that makes more sense actually. Excuse me. And we're going to make that equal to math with a capital dot random. Now what math.random will do is generate a random number between 0 to 1. It's going to give you like a very long decimal value, okay? So if we go here and we console.log the target. Let's bring up our terminal here and we run this. Oops, I'm running the wrong script as I was saying. So let's go to node and then script2.js. You can see we get a value like this. So what we essentially need to do if we want to generate a random number between a range or up to some specific value is we do the following. So let's say I want my random number to be between 10 and 100. The way that I need to do this is I say 10, which is the minimum possible value we can have, plus, and then I'm going to say math.round, and I'm going to take my math.random, and I'm going to multiply that by whatever the difference is between the maximum and the minimum. So let's say we want the maximum to be 100. Well, then I'm going to generate a random number up to 90. So I'm going to multiply this by 90, which is the asterisk operator, okay? So I take math.round, which is going to round this to the nearest whole number, okay? And we're going to take math.random and multiply that by 90. Now, when we do that, that's going to give us a random number between 0 and 90. So now we know the minimum will be 10, and then it can be anything between 10 and 100, because if we had this at the maximum of 90, that would give us 100, all right? Hopefully that's making sense, but that's how you do a random number within a range. A lot of times you just want to do a random number that is going to be like, say, 0 to 100. If that's the case, then you just take this and you multiply it by 100. It's important that you round this, though, because if you don't, you're going to get a decimal value, which you don't want. You want a whole number, right? So we're going to round this off. So now let's just print our target out, and notice we're going to get a bunch of different random numbers. Every time I run this, you should get something different, or not necessarily different, but something that is random. Okay, so there you go. We're generating a random number. Now that we have that, we want to continually ask the user to guess this number. If they go above it, we're going to tell them you're above. If they go below it, they're below. Otherwise, they got it correct. So let's set up a few variables here. First, we're going to say let, and this is going to be guesses, equal 0. Now, what we'll do is we'll add to this every time the user makes a new guess. Now, rather than doing this kind of constant asking right now, for now, what we'll do is just ask them one time, get that logic set up, then we'll move into that new piece of syntax we have not yet seen. Okay, so we're going to say that we'll actually use let guess equal, and actually, no, we can use constant, sorry, this is fine. We're going to say const guess is equal to, and this is going to be prompt, and we're going to say guess the number, and we'll just put 0 to 100 so they know the range. Then we're going to put colon and a space, and this is going to allow the user to type in a number. Now what we're going to do is we're going to compare this number to the target value and see if it's greater than or less than. However, remember that when we get a guess here, this is given to us as a string, right? So it's going to be like the string of 1 or 2 or whatever the user types in. So what we actually need to do is convert this guess into a number such that we can compare this against the guess, all right? Or against, sorry, not the guess, the target. So the way to do that is we're just going to take number here, and we're just going to wrap this whole prompt statement inside of this number function. All that's going to do is take whatever we type in here and convert that to a number. And just as a note, if you were to type in something that's not a number, something like hello, you're actually going to get what's kind of convenient, which is nan, standing for not a number. So if you type in not a number, number gives you not a number, which is actually a special type in JavaScript. In fact, we can have a look at this by saying console.log guess. Okay, and then running this. And if we type in hello, notice we get nan, right? Where if I type in something like 2, it gives us the number 2. And you can tell this is a number because it's highlighting in yellow. All right, so now we've converted our guess into a number. Now that we've done that, we're able to compare this against other numbers. So what I'm going to do is write an if statement. And for our if statement, we want to check if the guess is greater than or less than the target. How do we do that? Well, it's fairly intuitive. We're going to say if the guess is greater than, so I'm using the greater than sign, and then the target. Now, this is a valid comparison operator in JavaScript. This will compare either two strings, two numbers. It can actually compare pretty much any types, or quite a few types at least. In this case, when we use two numbers, it works exactly as you would expect. We're checking if the guess is greater than, because I usually think of it as like the alligator mouth is eating this value, is greater than target. Okay, if that is, for now, we'll just say console.log your guess is too high. Okay, and then we'll say otherwise, and then console.log. So let's do this. Your guess is too low. Now, I know there's an issue with this. If you already know what the problem is, feel free to point it out in the comments, or at least just make a note of it mentally. But right now, let's just see how this works, then I'll explain the problem. So let's run this, okay? And let's guess the number of, say, 56. This says our guess is too low. Now, in order for us to determine if this is working, we're just going to print out what the target value is, just so that we know. So actually, we need to do this before the guess. So we're going to say console.log target right here. Okay, just so we can kind of make sure this is functioning. So it's 16 is the actual number. So if we guess, say, 13, your guess is too low. Okay, run it again, 52. We guess 55, your guess is too high. So this is functioning. Now, the issue I was discussing is what happens if I actually guess the number, right? So in this case, I guess 0. It says your guess is too low, when really we've actually guessed the value. So this is where I'm going to introduce something known as the else if statement. Now, the way the else if statement works is it's an additional if that we will check if the first if is false. So what I can actually do here is I can go else if, and just like I wrote my original if statement, I can write another condition here. So I can say if the guess is less than the target. So now essentially the way this works is we check this first if statement. If this is true, we just execute this block and we skip checking this. If this is false, we go to the else if and we see if this is true. Now, the interesting thing with the else if is that you can put as many of these as you want, and you can kind of check a bunch of different conditions in a row and be able to skip checking them if one of them evaluates to true. So the advantage, again, is that if this is true, we don't check any of these. Whereas if what I were to do is remove the else's here and just put a bunch of ifs, what would happen is we would actually check every single one of these if statements because they're actually separate statements that aren't associated with each other. Whereas if we return to having our else's, all of these are kind of chained and put in one single statement, meaning only ever one of these kind of blocks will ever be entered, all right? So I just wanted to show that to you, but we're going to have this else if now. So if this isn't true, check this. If this is true, do this. And now we can add another else. So now what I'm doing is using the if else, where now in the else condition, we can say console.log, you guessed it. Now, the reason why this works here is because if I check if the guess is greater than the target, and it's not, and I check if the guess is less than the target, and it's not, then it must be the actual target, right? It must be the same thing. So if these two are false, it means we must have guessed the value. There's other ways we could arrange this statement. Just wanted to show that to you. So let's now run this. Okay, and now let's guess the number. Let's actually guess 56. Your guess is too low. Let's guess 2, and it says you guessed it, okay? So the statement is working as we expected. Now, one thing to mention here, just while we're at it, it is possible to use the less than or equal to operator. Exactly what it says, checks if it is less than or equivalent to the value. Same with the greater than or equal to operator. Okay, you also can use the not equal to operator. So exclamation point equals equals. If it is not equal to this, do the following, otherwise do this, etc. Okay, just wanted to show you those operators. Okay, so now that we have this, what we'd like to do is repeat this until they get it correct. How are we going to do that? Well, in JavaScript, we have something known as a while loop. Now, a while loop is a loop that will continue looping while a specific condition is true. So what I can do is put while, put a set of parentheses, and inside of here, just like my if statement, I put something that evaluates to true or false. So in this case, I'm actually just going to put the word true. Now, I could do something like while guesses is less than 10. And that means as soon as they hit 10 guesses, we're going to stop, right? So you can do whatever you want here for the condition, but just put something that evaluates to true or false. So in this case, we can just directly write true. Now what I'm going to do is take this kind of set of curly braces here, and I'm going to put all of this code inside of here. Now what's going to happen is we're going to do this loop continually, okay? So we're going to keep doing this forever until we break out of the while loop, which is something I'm going to show you. Now, right now, what we've done is we've written what's known as an infinite loop. This means we just keep going forever and ever and ever because this condition is always true. So what we need is a way to either make this condition false, or alternatively, we need to kind of manually exit this loop, which is what I'm going to show you how to do. So inside of the while loop, we have a few keywords. Now, one of the keywords is break. What break will do is immediately exit the closest internal loop. In this case, the closest loop is the while loop, so we're going to exit out of that by using the break keyword. So as soon as we see break, we're immediately going to stop executing the loop and go right down to what happens after the loop, okay? So now what we've actually done is we've implemented a loop that will continually keep asking you to guess until you get the answer correct. We'll keep adding to that, but for now, let's test this. So clear and run. And, oh, I didn't print out the guess. Okay, well, we can just kind of run this. Let's guess 50. It's too low. Let's guess 75. Too high. Okay, let's guess 66. Too high. Let's guess 60. Too high. Okay, 55. Too low. 57. Too low. 58. 59. And we guessed the value. Okay, so you can see we exit out of the loop and we stop asking because we got it and we broke using this break keyword. Great. So that's how the while loop works. Now what we want to do is keep track of how many guesses the user has. So what we can do is we can simply go to the top of our while loop here and we can say guesses plus plus. This is going to add one guess every time we enter this loop, right? Because we're just going to keep repeating this code. So then what we can do down here is we can say console.log, you guessed the number in comma guesses comma tries. Okay, exclamation point like that, and it will tell us, how many guesses this took. Now that's pretty much going to complete the program, but let's go up here and just test this out. Okay, so guess the number, 50, too high, 25, too low, 37, too high, 30, okay, 34, 33, 32. You guessed it, and you guessed the number in 7 tries. Okay. So I think actually that's going to wrap up our number guessing program. Just a few kind of final educational moments here, I guess. Inside of this while loop, obviously we can use this break, which is what I'm doing, but we also have the option to use another keyword, which is known as continue. Now I won't demonstrate the use case of this, but all this is going to do is immediately restart the loop, okay? So what I could do here, and this isn't really ideal, but we can write it in this way, is the following, okay? This is just kind of an illustration of how this works. I could actually put a continue keyword here, a continue keyword here, and a break keyword here. Now, what this will do is if we enter into this statement, and this can be an else if actually as well, then we're going to continue. Now, what that means is bring us to the beginning of the loop. Don't continue executing anything after the continue statement. So if the guess is greater than the target, don't go down here, just continue the loop again. And then down here, same thing. If it's not greater than the target, but is less than the target, continue, bringing us back to the top of the loop. And then if for some reason it's not any of these, so if we did actually guess the value, then we print you guessed it and we break, right? Which is down here, exiting the while loop. This is a very anti-pattern way to write this. I wouldn't suggest you write it this way, but I'm just demonstrating the use case, right? So if I go here, we can do this too low, 75, too low, 95, too high, 90, 93, 92. Okay, you guessed it, and then notice this works exactly as it functioned before. Okay, I think that's going to wrap it up. Let's move on to the next project. All right, so the next project I have for you is a rock, paper, scissors game. This idea is that we're just going to ask the user if they want to be rock, paper, scissors. We're then randomly going to pick for the computer rock, paper, scissors. And we're just going to see how many wins, losses, or draws that they have at the end of the program. Let's go ahead and start writing this. So I've created another script file. Again, I'm going to take my prompt and just paste this in here. I'm going to go a bit faster this time, and I'll write kind of some more code and then slow it down. So let's make a few variables. We're going to say let wins equal 0, let losses equal 0, and let ties equal 0. Okay, now what we'll need to do is we'll need to ask the user if they want to be rock, paper, scissors, and then generate kind of a random value and determine if the computer is rock, paper, or scissors. So we're going to say const choice, or choice, I guess, is equal to prompt, and then we'll say enter rock, paper, or scissors like that. Okay. And we'll allow them to enter something. Now what I want to do is I need to make sure the user actually entered one of these valid options. If they did, then we'll continue. Otherwise, we need to ask them to retry. We're going to put this inside of a while loop, but I like to write some more logic before we do that. So I'm going to show you something new here. I'm going to say if choice is equal to rock, or choice is equal to paper, or choice is equal to scissors. And we're going to put a triple equal sign here as well, like I was mentioning. So what I'm actually checking here is 3 conditions in one, and I'm chaining them together using something known as a logical operator, which we've not yet seen. Now, this double pipe operator here acts as an OR, okay? So it's equivalent to writing OR. Essentially what that means is if the left side or the right side is true, then the whole expression evaluates to true. Now, in this case, I've confused you intentionally by writing actually 2 sets of ORs, but all this is checking when we put the ORs kind of chained like this is if any of these conditions are true, meaning they typed in rock, paper, or they typed in scissors, okay? You have to chain it like this, how I've written it, but if any 3 of these things are true, it evaluates to true. So we evaluate each individual condition. Only one of them can ever be true, but as long as one of them is true, we go in here. Otherwise, we would need to say something like console.log, okay? And then we're going to say, please enter a valid choice, okay? And in fact, I'm actually just going to reverse this just because I think this will be a bit educational. Rather than putting the else here, I'm just going to put this in the if, and I'm actually going to negate this. I'm going to say if choice does not equal rock, and I'm going to use something called an and choice does not equal paper, and choice does not equal scissors, okay? So now I've just reversed the condition so that you can see how we do this in the opposite direction using the other logical operator. This operator is the and. It works opposite to the or. Both the left and the right-hand side need to be true. So in this case, I'm saying all 3 of these need to be true to enter into this, otherwise don't enter. And then I've negated the condition, so rather than checking if it is true, I'm checking if it's not true. So I'm saying if the choice is not equal to rock, and the choice is not equal to paper, and the choice is not equal to scissors, so if it's not any of the valid options, tell them enter a valid choice. Let's just quickly test that before we go any further. So we're going to clear and run script 3, and notice that if I type in something like R, it says please enter a valid choice, whereas if I type rock, that is fine. Okay, so that is working. I know that's new, but wanted to show that to you. All right, so if they enter a valid choice, then what we do is randomly pick something for the computer. So how are we going to do this? We're going to say random, and in this case, I'm actually going to say index, I'm going to teach you something new again, is equal to, and this is going to be math.random, and we're going to multiply this by 2, and we're going to say math.round, and then round this. Now, the idea is this is going to give us a value of 0, 1, or 2, which we're going to use as an index for something known as an array. Now, I'm actually going to put const choices is equal to an array. I'm going to say rock, paper, scissors, like this. Now, an array is a ordered collection of elements, okay? So what I do is I put a set of square brackets. This defines an array. Now, every element in our array is accessible by an index. An index is an integer that represents the position of the element. So the first element, rock here, is indexable or accessible by index 0. Paper, indexable or accessible by index 1. And scissors, index 2, okay? So what I've done is I've generated a random index, which will correspond to either 0, 1, or 2, which then in turn corresponds to rock, paper, or scissors, right? That's it. That's all we're doing. So that's kind of what we're doing. The reason I do it out of 2 is because, well, the max index is 2. It's always going to be 1 less than the length of the array. There's a lot more to talk about with arrays. We're not going to get into all of it, but I just wanted to show you a simple use case right here. Okay, choices, random index. Now we need to generate the computer choice. So we're going to say const computer choice is equal to choices. And the way we access an index of an element is use a set of square brackets, and then we place in here random index, which is the index we want to use. So if I put 0, that gives me rock. If I put 1, that gives me paper. If I put 2, that gives me scissors. In this case, we'll use random index because that'll be the random value. Now, because we're not quite done, we're going to say console.log the computer choice. Okay, we're going to clear and run, and we'll do something like rock, and then notice it gives us paper. Now let's run this again. Let's do paper. Gives us paper. I just want to give me something different. Gives me scissors. Okay, so you can see it's randomly generating something for the computer. Okay, perfect. So now that we have all of that, we're just going to check if the computer beats the player. How are we going to do this? Well, the first thing we can check for is if we have a draw. If we don't have a draw, then we can check the 3 different conditions that result in a win for the player. If they don't win, they lose. There's a bunch of different ways to check this, but it is unnecessary to check all 9 different combinations because of the fact that we can exclude the draws and we only need to check for a win condition. So you'll see what I mean, but I can say if the computer choice is equal to the choice, which is really the player choice. And what I'll do is I'll just show you in VS Code. What I can do is I can highlight this and I can hit Control H or Control F. And then I press this little button here, standing for find and replace. And I can actually put a string to replace this with. So I can say player choice like that. And then I can put this capitalization here and this little underscore. And now you'll see what this does is it only selects where we just have choice. Whereas if I remove these, it's selecting like choices and it would select like the capital choice. But if I put both these on, I'm matching the spacing and I'm matching the capitalization. And now I can press this little button that says replace all, and it just replaces all of those for me, okay? So anyways, now that I've done that, I have if computer choice is equal to player choice, then we drew, right? So I'm going to console.log draw. And then I'm going to say ties plus plus. Again, we're going to put all of this in a while loop in a second, but for now, I just like to write all of the logic kind of at once. Okay, so we're checking if they drew. If we didn't draw, then we're going to check if the player beat the computer. And if we didn't beat the computer, then we lost. Now, there's 3 conditions where we beat the computer, right? So we're going to say else if the player choice is equal to, and in this case, we'll say this is paper, and the computer choice is equal to rock, then we won, right? So we could say console.log 1. And then we can say wins plus plus. Now what I could do is write another else if statement and just do the same thing and check if we are rock and the computer's paper, or we can do all the other win conditions, or I can just chain them inside of here. Now, it might get a little bit confusing, but let's do it anyways because the whole point is to learn here. I'm going to put these in a set of parentheses. This is our first winning condition, right? If all of this is true, if the player chose paper and the computer chose rock, we won. Now, what's the other winning condition? Well, the other winning condition is, let's just copy this and paste this here. And you're going to see it goes on a new line for us, so it kind of formats it. Anyways, now I'm going to say if the player chose rock and the computer chose paper, then we won. Okay, so that's the next winning condition. So notice I've put these in a set of parentheses because I need to kind of separate them out. So we have the first winning condition, second winning condition, and now the third winning condition. And I'm going to check if any of these 3 winning conditions are true, because if they are, we won, right? Which is why I'm separating these larger conditions with the or statement. So now, rather than paper, rock, we're going to say, okay, scissors, and sorry, I realize this is rock and this needs to be scissors, okay? So we're going to say if the player chose scissors and the computer chose paper, then we won. Now, maybe I'm crazy, but I'm pretty sure these are the only conditions in which we win. So now we handle that, and then we have an else, and we say, okay, if we didn't tie and we didn't win, we must have lost. So we say const.log lost, and then we type losses plus plus. All right, so that wraps that up. What I'm quickly going to do is I'm just going to add another console.log here, and I'm going to say the computer chose, colon, comma, and then computer choice. And we actually don't need the space because it will automatically add it. Let's just zoom out a little bit because I know that's getting a bit hard to see. So we have our 3 variables, right? We ask them to enter rock, paper, scissors. We make sure they selected something that's valid. Now we haven't actually put this in a while loop yet, which we will do. For now, this is just going to tell them to enter something valid, even though we'd continue with the program. In a second, we're going to not do that. Anyways, we pick what the computer has selected, okay? We print out what they selected, and then we check if they won, if they lost, etc., right? Saying, okay, if it's the same, then we draw. So we say that. Otherwise, we check the 3 winning conditions, win, otherwise, loss. All right, let's run this. Enter rock, paper, scissors, enter rock. The computer chose paper, you lost. Okay, perfect, let's continue. Enter rock, paper, scissors, paper, the computer chose scissors. All right, seeming like this is rigged, but let's see. Scissors, the computer chose paper, you won. Okay, nice. So you can see this is working. However, we want to now continue essentially until the user tells us to stop. So now how do we do that? Well, we use a while loop. So all we do is we take all the code we want to repeat. We're going to go here and we're going to say while true. Okay. And we're going to wrap everything inside of here. So now we have a while loop, which means we're just going to continually do this. All right. And then what we need is a way to exit the loop. Now, first of all, let's go here and put a continue statement. So continue like that. Now, the reason we're going to put continue is because if the user does not select a valid value here, then we're just going to tell them to kind of go again, right? So we'll repeat the while loop right from the beginning, which just means we're going to continue repeating this portion of code until they give us a valid value. Okay, please enter valid. This is going to be choice. All right, nice. Then we'll do all of this. And then what we'd probably want to do is once we exit the loop, or we need a way to exit the loop, sorry. So I'm going to say enter rock, paper, scissors. And then I'm going to put in parentheses or Q to quit. Okay. First, I'm going to check if they typed in Q. So I'm going to say if player choice equals Q, then I can just go here and I can say break. So it's just going to exit the while loop for us. Okay. So if they enter that, let's quit. And we can even convert this to lowercase so that if they type in uppercase Q, we still quit. All right. Then lastly, we'll go down here and we'll just say console.log. It will just print out their record. So we'll say wins, losses, and then ties, ties like that. Okay, I think that's going to be it. Let's run this though and give it a test. Okay, so let's just try to quit. Okay, so notice, there you go, that works. Let's enter, let me zoom in a bit here. Rock, okay, computer chose scissors, you won, all right. Let's enter paper, excuse me. Okay, scissors, let's enter something invalid. Okay, please enter a valid choice. So let's go paper and let's quit. It says 2 wins, 1 loss, and 1 tie. All right, so I think with that said, that's going to wrap up this project. This is definitely the hardest one so far. I wanted to go a bit more challenging and show you some more different operators and things that we can use, but hopefully you guys were able to complete this and most of the code that you see here makes sense. Now, let's move on to the last project, which is a choose your own adventure game. All right, so this project is going to be a fast one with the idea that you can extend this and make it as complicated as you want. I'm just going to show you probably in about 5 minutes the structure of a project like this, but it's really extensible and something that you could even kind of combine with some of the other projects. The idea is want to have a choose your own adventure game. The point is that we have all these different nested paths that we can go down. So you might have seen those books before where it's like, do you want to fight the dragon with the sword or do you want to run away? And then it says, if you decide to fight, turn to page 35. If you decide to run, go to page 53. A lot of kids' books are kind of like that, right? Where you're picking the path you want to go down. And depending on the decision you make, you're going to either win or you're going to lose or you're going to end up in a different position. That's what we can do with code. I'm just going to start coding it for you and you'll see very, very quickly how you can kind of work on this on your own. All right. So the idea is we're going to first need to ask the user for some information. So we're going to take this prompt and we'll start with something like const answer is equal to prompt. And the first thing we might ask is something like, would you like to play ? And I usually just put what I expect the answer to be inside of parentheses so that the user knows what to type. So y or no, okay? So we're going to say if answer dot to lowercase is equal to yes, then we'll play. Otherwise, we'll console.log and we'll say that's too bad. Okay, so that's kind of the first decision, right? Do they want to play? Yes or no? All right. Now, only if they said they want to play do we ask them the next question, which means we put that question inside of this if statement. So I'm going to say const answer to is equal to prompt would you like to go left or go right ? Okay, and then we're just going to put here left/right. Now I do the same thing. I check if they answered left, we do this. If they answered right, go here. If you want, you can say if they didn't answer correctly, maybe you ask them to do it again, or you can just end the game. You can pick what you want if they give an invalid answer. I'm just going to essentially check for one answer. If they don't give me that, I'm going to assume it's the other one. So I'm going to say if answer 2 is equal to left, then I'm going to do something here. Otherwise, we're going to assume it's right. We're going to do something here. So I can actually make a comment. A comment is some code that will be ignored by your program, by the way. If I do 2 slashes, just to indicate this else statement is what happens if I go right. So let's say we go left, and I do something like console.log. Oops, you go left and fall off a bridge. bit extreme here, but you get the idea. You lost. Okay, so left was not the correct path, so they have to go right. So if they go right, we can do something like console.log. Nice. You go right and approach a bridge. Okay, you can be as creative here as you want. And then I can ask another question. So I can say const answer 3 is equal to prompt. And I can say, would you like to cross the bridge? Or we can say something like turn around and find another way. And then we'll put as the potential answers here, cross/turn. Okay. Excuse me. Same thing, we come down here. Let's just make this a little bit larger. And we now put another if statement, and we say if answer 3 is equal to cross, then you do something here. Otherwise, you do something here. Now, I don't really want to continue too far with this, so I'm just going to say console.log. You cross the bridge and reach the end of the game. Okay. Otherwise, we can say something like console.log. You turn back and trip on a log and hurt your leg. You lose. Okay. So the whole point of what I'm trying to show you here is that we can nest these different blocks inside of each other. Okay. So I've done this very, very simply because I'm just trying to illustrate this to you quickly because this is a project that's really meant for you to work on your own. But the point is that we only go into one block if the other block is true. So if this is correct, right, so if we do want to play, then we ask the first question. Depending on the answer to the first question, we now branch off and we go to the left or we go to the right. So in this case, if we go to the left, you lose, but you could make it so that each answer could potentially lead you to the correct scenario, right? The whole point is that you can infinitely branch as much as you want by nesting these statements. So that's what we're doing. We have this, all right? We say otherwise, so if you didn't answer left, you're going right. Okay, nice, you approach bridge, ask you another question, and then again, we check inside of here, and only inside of here, what the correct answer is. So if you cross, okay, you won the game, otherwise you lose, but we could just make it so you continue going down a bunch of other decisions. Now, you can even make this more complicated where you have previous decisions impact future decisions. Now, they already do, but what I mean by that is at the beginning of the game, you can ask something like, what weapon would you like to select? Do you want to wear boots or do you want to wear sandals? Do you want to wear a hat or do you want to take this? And you can kind of, collect some different items, for example, and then you can use those items later in the game. So eventually, maybe you reach a dragon or something, and you can say, oops, you didn't bring your sword with you, so you lose the game because you can't fight the dragon. So the decision they made maybe 20 steps ago is now affecting them here, and they have to restart, get all the way back there, but make sure they make the correct decision. So let me run this just so you get an idea of how it works. Okay, so sorry, we don't want script 3, so close that. We want script 4. Would you like to play? Yes. Do you want to go left or right? We go left, and it says we lost, right? So we can run it again. Yes. Let's go right. Nice. You go right and approach a bridge. Would you like to cross the bridge or turn around and find another way? Let's cross, and we win. But again, you can see if we go the wrong way, so I decide to turn, it says you turn back and trip on a log and hurt your leg. You lost. You get the point. That's how the game functions. Now, I actually worked as a kind of coding teacher at a summer camp where I was teaching kids who are between about 10 and 15 how to make this exact game. This was kind of the final project they worked on at the end of the week. And I'll just say that they came up with some super creative and really interesting projects where they had like hundreds of lines of code, 20, 30, 40 different paths, and they absolutely loved it. It was super, super fun. So I know this is a simple, relatively simple thing to do, but it makes really interesting games and something that's really cool that you can show to your friends, family, whatever, and you can see if they can actually get to the correct path. And obviously, the more complex and more interesting you make it, the better the game's going to be. So please make something like this, extend it. You even could do something crazy where one of the paths requires you to play rock, paper, scissors. And if you lose, then you lose, right? And you have to go back and do it again. So all kinds of interesting stuff you can do. Anyways, with that said, I think I'm going to wrap up the video here. All of this code will be available from the description in case you'd like to download it and play along with it. And again, remember, I do have a programming course called programmingexpert.io for any of you that are really serious about getting better at programming. If you enjoyed this video, please give me a like, subscribe to the channel, leave a comment, let me know what you thought of it, and I look forward to seeing you in the next one.